Hello, everyone. Welcome to Voyager National Park Association's Night Explorer series. As you know, VNPA, Voyager's National Park Association, we partner with the National Park Service to support the park as stewardship, education, funding, and one of those things that we do is help in preserving and celebrating our dark skies. And we have our volunteer here, Astro Bob King, today, and he's going to talk to you about how Mars gets bigger, brighter, and closer. Before we do that, I want to give you a few reminders. If you're interested in becoming part of our Voyagers National Park Association, you can find out more about us and become part of the community at voyagers.org, and we'll have a slide at the end where you can find out more about us. And also, if you're interested in finding more about Astro Bob, we have his blog website right here, astrobob@areavoices.com. And just the usual reminders that make sure that you have your video muted and your sound muted so that you don't end up displaying yourself to all of the people that are watching. We'll use the chat box to provide you with information. And if you have questions for Astro Bob as we go along, be sure to type them at any time. And then at the end, we'll have Astro Bob answer all of your questions. So just as a review again, that we have Astro Bob here. He's going to talk to you about how Mars gets bigger, brighter, and closer. So thank you for joining us today.
Thank you very much, Jackie, and welcome everyone. Good to have you all back here at the screen so we can talk about what's up above our heads. Today's topic is going to be the planet Mars, but I do want to touch on a couple of little things, at least make note of them before we start on Mars. The first being the Persei meteor shower. I do hope you had an opportunity to get out one of those nights, August 11th, 12th, 13th, whichever, and at least see a few of those wonderful meteors and swap stories with others about them. And hopefully your kids, if you have children, got a chance to see them too. We also have an announcement here I want to make, especially for our northern viewers. The Northern Lights, there's a possibility we'll be seeing the Aurora Borealis tomorrow evening. That would be Wednesday, August the 19th, beginning roughly around 10 o'clock, 11, 12, sometime in that time slot. Once it gets dark, usually the aurora is more active around midnight, 1 a.m., so it might be kind of a late thing. But right now we have a forecast because there was a flare on the sun and it kicked out a little bit of an explosion, and that's headed towards the Earth right now at this very moment. And it will arrive tomorrow night. So if you can, go to the country. We don't have a bright moon in the sky, just a very thin crescent. And look to the north and do a little bit of a visual and see if you can't maybe catch a little bit of that glow, that pale green, kind of a low rainbow shape called an arc. That's usually the start of an auroral storm. So maybe tomorrow night, we'll see, crossing my fingers. Today we're going to talk about Mars, though, because I can't help but notice it. We've seen Jupiter and Saturn, right? Throughout the whole summer and in the spring even, we see those two bright planets. And I'm pointing to the south here from my computer. We see two bright planets in the southern sky. The brighter, of course, is Jupiter, and next to it is Saturn. But we have another bright planet that is now on its way up in the eastern sky. So we are going to take a look at that right here. And I hope you can see our screen. I've got a slide presentation I prepared for today. Just to start out with the evening view looking to the south, we have, I hope you can see all the way to the right on your screen. You should see right down there in the corner, the Crescent Moon, because on the 20th of August, not tomorrow night because it's still a little bit too close to the sun, but the moon is going to return to the evening sky this week, and you'll see a really beautiful crescent coming up in the direction of the sunset about an hour after sunset in the western sky. And this view of the sky is quite broad. It begins off to the south, or pardon me, the west, spans the southwest, south, and goes all the way southeast, where you can see Jupiter and Saturn paired up there. right above the Teapot constellation called Sagittarius. There are also two bright stars visible across the southern sky, one low, and it's orange-red colored. It's called Antares. It's the brightest star in Scorpius, the Scorpion. And then there's one that's up high, and it's even brighter than Antares, and it's Arcturus in the constellation of the Herdsman, otherwise known as Boötes. Now, if we turn around and pivot and face to the east at around 11:30, you guys up for staying up late? Mars actually starts to make its first appearance right around 11 o'clock in the evening, but it's really, you have to wait till about 11:30 before it starts clearing those trees down there. And when it does, you can't miss it. It's like this brilliant orange-red beacon of light, and it's really getting bright now, so it's becoming very prominent. As a matter of fact, Mars is now brighter than the brightest star in the entire sky. That star is, I'll give you 3 seconds to answer. If you answered Sirius, you're correct. Brighter than the brightest star, and a remarkable red color. Of course, that red color, here it is down here, that red color inspired the name Mars, which is the Roman god of war. So the red color referring to blood and battle. So we have that red. It's always an association with that planet. It's located, again, at around 11:30, low in the east, in this faint constellation. You can see this, it's called Pisces the Fish. There's really nothing bright in this constellation. That makes Mars really stand out even more. But you can use Mars to find a favorite fall constellation called the Great Square of Pegasus. It's right above Mars, and it's shaped kind of like a baseball diamond. That's Pegasus. So that's in the eastern sky at around 11:30 in the evening. Let's look at the planet itself. We're going to do all kinds of fun things with Mars, but let's get a few facts before we continue on that journey. It's a really cold place. I mean, we in Duluth and certainly northern Minnesota, we really get frozen during the winter time, and a lot of you are familiar with that. But the average temperature on Mars is 60 below zero Fahrenheit. So it's much, much colder than Earth on average. At the poles of Mars, the temperature goes down to around 200 degrees below zero. And in most places on the surface, it's well below zero every single night of the Martian year. However, Mars has low areas, and under a high sun, the temperature there in its very thin atmosphere can get up to about 80 degrees for short periods of time. Problem is that atmosphere, right? It's made of carbon dioxide almost completely, 95%. And the pressure is less than 1% of that on Earth. So it's very thin air, and that air does not hold the heat. So the temperature drops very low at night on Mars, and it warms up in the daytime. Although Mars is small, you can see it's only twice the size, or pardon me, half the size of the Earth, or twice the size of our moon. Although it's small, it possesses some of the most remarkably large things in the entire solar system, including it has the tallest mountain, which happens to be a volcano, and it also has the biggest canyon in the solar system. Most interestingly for us, and the reason for our incredible fascination with Mars and why we keep sending spacecraft there all the time, is because we are looking for liquid water. There are signs that at one time in the past, liquid water flowed on the planet. And it may still be there now, for all we know, in underground springs. And whenever there is water, there's always a possibility that there might be life, because life is so dependent upon it. Here's what Mars looks like now. If you had a telescope and you went outside and you looked at this planet, remember, it is kind of small. You saw it's half the size of the Earth, and it's still many millions of miles from us. So it looks like a little tiny ball through the telescope. Definitely reddish orange, just the way you see it in the photograph. And what's really cool is through your telescope, if you magnify like 100 times in the scope, you don't need a giant telescope, just a modest one. You magnify 100 times, you will see a bright white button, little cap at one end of Mars at its south pole. That's the south polar cap. Right now, that cap is vaporizing in the heat because it's spring there. So the cap is shrinking, but it's still big enough right now to see through a telescope. You can also see dark markings on the planet. Some of these markings are the remnants of extinct dormant volcanoes. Mars is the only planet in the entire solar system, besides the Earth, where you can actually see detailed surface features from the Earth. Everything else is covered in clouds, or Mercury, which you could see the surface is so tiny and far away, it's almost impossible to do it with a regular telescope. What a place, all right? Very cold, dusty. When it heats up on Mars, sometimes you get these little twisters, these whirlwinds that form, and this is an animation of multiple little dust devils that was taken by one of the rovers on the surface of the planet. Isn't that cool? You can almost picture yourself there with these things whirling by you. Mars also has clouds, and this is another animation, multiple pictures of a cloud formation. And the clouds on Mars are made out of water vapor, like the Earth's clouds too. It doesn't have super dense clouds like we do, like thunderstorm type clouds, but it does have high, thin clouds that if you went there, you'd actually go, those look familiar. How many of you saw The Martian, I wonder? This is one of my favorite movies. It got a lot of things right about Mars and just a couple of things wrong. Right in the beginning, there was a huge storm for those who saw the movie, and it knocked over and destroyed the equipment, and it led to the plot for the rest of the movie, basically. Well, Mars does have powerful dust storms. No question about that, 60, 70 mile an hour winds. But remember, the atmosphere is so thin that even with that powerful of wind, it feels like a breeze on Earth would to us. 8 miles an hour. Big storm on Mars, you could stand out there, you'd hardly feel it. It would feel like a summer day's breeze. So, of course, if they had removed that element from The Martian, it would not have been as exciting a movie as it was. Speaking of a mission to Mars, as the movie was all about a mission to Mars, and there's talk now of going to Mars sometime in the next 10, 20 years, perhaps, a Mars mission. A human mission there would require about 1 year and 4 months to complete. It's a long journey, many millions of miles away. You'd have to wait till Earth and Mars were relatively near one another. And the time to get there is 7 months, maybe as little as 6, maybe as much as 8, but about 7 is the normal amount. And that's a typical long stay on the International Space Station. Of course, after you've gone that far, you would stay a couple of months, and then you'd need all that time to come home. So the whole mission in space would be more than a year. The reason why Mars is interesting right now and why it really catches our eye is because the two planets, Earth and Mars, are getting closer and closer together. And as they do, Mars gets brighter and brighter and appears larger in the sky, so it really starts to attract our eye, get our attention. This happens about once every 2 years when the two planets line up. Here's the Earth. Okay, we are closer to the sun. There's our orbit. Because we're closer to the sun, we go around faster, right? Mars is further from the sun, so it moves more slowly than the Earth. So about every 2 years, the Earth laps it the way a runner would in a race, on a track, at a stadium. It laps Mars. When we lap Mars like that, that's when the two planets are closest. And we're coming up to that time this year in October. So that's why Mars is getting closer and brighter to us. Now, not every, by the way, that time is called opposition. When the two planets are at their closest, that's opposition. And it's because Mars appears opposite in the sky from the sun. So as the sun sets, Mars rises. Earth's in the middle. So Mars reaches opposition once every 2 years approximately, but not all oppositions are the same because Mars is this really weird, wonky orbit. The Earth's orbit is almost a perfect circle, very close, whereas Mars's orbit is an ellipse. It was almost like someone sat on the circle and squished it a little bit. In an ellipse, the sun is off to one side of the orbit. So when a planet goes around the sun in a squashed ellipse like Mars, it's closest to the sun on one end of its orbit and furthest from the sun on the other end of the orbit. Now, when Earth laps it when it's closest to the sun, I'm pointing out when that happened in July of 2018, then we're really close to Mars. And it's even bigger and brighter than it will be in October this year. Here's the opposition that will happen this year, October 13th. That's when our two planets will line up. The Earth will pass Mars. And for a brief time, it'll be extra close and bright in the sky. Future oppositions, Mars keeps moving further from the sun in its wonky orbit when the Earth passes it. As Earth approaches Mars, as it's doing right now, and it'll continue to do right into October until October, early October, when it will be just 38.6 million miles from Mars. Now that sounds like a really huge distance, and it actually is in human terms, but in planet terms, that's close. And the two planets will be closer in October than they will again until the year 2035. So this is really a great time to get out, get to know the planet, watch its travels in the sky, watch for interesting conjunctions when the moon pairs up with it. And maybe if you have a telescope, to point that scope at Mars and see if you can spot that polar cap and other features. This is what happens during an opposition. Before we're closest, as the Earth is catching up, Mars is small, but it gets bigger and bigger and bigger as we get closer and closer. And of course, then it shrinks as we pass by and it fades. Here's what we see through the telescope. Again, you can see the polar cap. You see these really wonderful surface features. You can even see dust storms, which look like little orange puffs on the surface, if you're lucky enough to catch one of those. I have a link with this lesson for a Mars map and another link that will help you know which side of Mars is facing you when you go out with a telescope so that you can go out and identify features on the planet in the coming months. Dust storms are wonderful, but my gosh, on Mars, it also, by the way, has the biggest dust storms of any planet in the solar system. On Mars, sometimes a small storm or a regional storm can develop into a monster dust storm that can cover the entire planet. This last happened just at the last opposition in June, July of 2018. We were all so excited, looking forward to point our scopes at Mars and see all these amazing surface features. And look what happened. In a month, it went from clear to completely dust covered. It's amazing in a way though, but you could see that in a telescope. Even though you can't see those features anymore and the cap was gone, you're actually witnessing a violent storm right here on another planet through your telescope. Let's hope that doesn't happen though this time around. It's more interesting actually to see the features on the planet. And Mars is host to many amazing sights. I think about our descendants far in the future who will go to Mars and ply the paths of the planet, who will scale the mountains, explore the ancient river valleys, and maybe, just maybe, they'll climb the slopes of Olympus Mons, or Mount Olympus, which is an extinct volcano and the largest mountain in the entire solar system. I'm going to show you how big this thing is. All right. You could fill it up, the whole state of Arizona. You could fill the whole state with Olympus Mons, Mount Olympus. Look at that monster. 374 miles wide, 16 miles high. Definitely going to take someone a lot of time to climb to the summit of that crater, or that, actually the crater, the caldera of that volcano. Extinct though, it was probably active 2 to 3 billion years ago, back in Mars' early history. Mars also has the grandest of the Grand Canyons in the solar system. Maybe you've been to our Grand Canyon, and it is a spectacular sight, the beautiful layered walls. It's a beautiful monument made by nature, carved by the Colorado River. On Mars, rather than a river, the planet actually split and created this enormous canyon. Look at this thing. It's called the Valley of the Mariners, or Valles Marineris. And here's how big this is. It looks huge here, right? And by the way, these are some of the other Martian volcanoes, also extinct, off to the left side of that picture. This is how big it is. We've got a map of the United States laid over this canyon. And you can see that it extends all the way here from the Carolinas to, California. So that is truly an enormous feature. So for a small planet, Mars does well. Then there's the famous face on Mars. Have you guys heard about this? Back in the early days when we were first taking images of the planet from orbit, this was taken by the Viking orbiter back in the 1970s. The resolution was low, right? It wasn't as crisp. We didn't have as good a cameras as we have now. And so light and shadow played tricks on our eyes. And people studying these images, some people looked at them and said, hey, look at this. That's a face in that mountain. Someone must have carved that. Well, we see faces in lots of things, right? We see faces in clouds and floor tiles, and we also see them in features on Mars, especially when things are a little blurry, when there's not a lot of crispness or resolution, as it's called. But look what happens when you increase the resolution, as we did when we flew better cameras into Mars orbit. I think I've got a couple of pictures here. And here you see, oh, I'm just kidding. Apparently it turns out to be Elvis. So it really is a face on Mars, the face of Elvis Presley. It's there. Sorry, that was my attempt at a joke. This is what it really looks like, of course, when you bring up the high resolution. And what we're looking at is basically a mesa, right? It's like a hill, and it's very eroded. And because of the play of light and shadow again and low resolution, it looked like this in the early images down here, but now we see it for what it is. It eliminates the uncertainty, does it, when we get extra data. Well, we've got lots of interesting things happening on Mars right now, besides looking at it and enjoying the view, watching it rise and so forth. From Earth, we have our emissaries there, our rovers, and our instruments on the planet that are studying it and sending back data all the time. For instance, right now on the planet, there are two active missions. One is called the Mars Insight Lander, and what it's doing, it's using its seismometer, that's this instrument right down here, to record Mars quakes. And since, my gosh, it's recorded hundreds of them. I don't have the exact number, but earlier this year, they had counted 450 Mars quakes, which is incredible. Most of those Mars quakes are not caused by things that cause earthquakes on Earth, which are moving tectonic plates that pull apart or crash together. Instead, on Mars, quakes happen because the planet is still cooling and shrinking from the days when it was first born, and it was very hot, just like all the planets. And as it shrinks, the crust cracks to accommodate the smaller body, the smaller size of the planet. And this instrument is picking up all of that information. Here's a picture of it live, what it looks like if you were down there in a spacesuit and took a look. It's protected from any wind and things like that by a special cover, so it can really hear, pick up sensitivity of earthquakes. The greatest quake it's recorded so far is only 3 on the Richter scale. So nothing that would, like, you would feel it, but it wouldn't like tear your road in half or something like that. Not a major quake. The other instrument or rover that's on Mars is NASA's Curiosity rover. It has been chugging along on the red planet ever since August of 2012. And it's studying the rocks there, trying to determine if Mars was once a suitable environment for life to form. And it has proven that beyond a doubt. It landed in a crater called Gale. Crater's like 90 some miles across. And in the center of it, there's this little peak called Mount Sharp. And here was the Curiosity, landed right there. And the rover, since it landed, has been exploring in this area and gradually working its way up the slope of Mount Sharp, taking pictures, drilling into the rocks to take samples, and discovering that the area was once rich in water. It left behind minerals that could only be created by flowing water. Take a look at this. You're looking at Mount Sharp and you're seeing all these sedimentary layers. Now, some of these are probably caused by wind-blown dust, but some of them were left by as sediments when a lake evaporated and it deposited its debris behind as a layer. So that layering really tells us something interesting about the red planet, that it was once wet. Here's a fascinating find: pebbles. These pebbles aren't just rough-edged rocks. They are rounded. Look at how round each one, very rounded shape. These guys have been tumbled round and around by a river. They rolled around in a river that flowed through Gale Crater once upon a time. They were eroded, just the way you'd see pebbles at a beach, a clear sign that water once filled that crater. In fact, this is a wonderful illustration showing what Gale Crater probably looked like 2 to 3 billion years ago. That's when Mars actually had a nice climate. You could go there on vacation. Of course, we weren't around 2 to 3 billion years ago when Mars was more clement. There are abundant signs of water on Mars, which is, again, what makes it such a fascinating planet. Here are some dried riverbeds. Here is a water outflow, and it ripped away, eroded away a lot of the river base, or the bottom of the river, and created these teardrop-shaped islands. Aren't those beautiful? Clear sign that water once flowed violently even through this channel to create these beautiful islands. On Mars right now, we haven't identified liquid water, maybe a couple droplets at a spacecraft that landed called the Phoenix spacecraft. But Mars is so cold than any liquid water on the surface. And it also has such a thin atmosphere that any liquid water would just vaporize into space. There's not enough pressure, air pressure, to preserve it as water. It would just turn to vapor and disappear. But much water and frozen carbon dioxide, basically dry ice, is locked up in the planet's crust and in its poles. This is a picture of one of the Martian poles where you can see frozen carbon dioxide there. Spectacular view. We have another mission on the way to Mars, and this one, we're getting closer to actually bringing back samples. This is the next step after Curiosity, where we're going to be bringing back samples. It's called the Perseverance. It's called Mars 2020, and in that 2020 mission, this rover was packed, and the rover's name is Perseverance. Launched on the 30th of July, it's going to arrive next February. Its job is to look for signs of ancient life in rocks, to pick up interesting looking rocks using its drill, gathering soil, gathering rocks, measuring their chemicals, and deciding this looks like it potentially could harbor ancient microbes, bacteria. Then it will gather at least 30 samples, very narrow pencil-like tubes of samples, and it will take those samples and it will store them somewhere safely nearby. Then sometime later, NASA will send a second spacecraft to Mars, put another lander, put it right down there where the samples are. This lander is equipped with a rocket. The lander will grab the samples, store them safely in the rocket. That rocket will launch and rendezvous with the spacecraft in orbit. And then that spacecraft will carry the samples back to the Earth, where they'll be studied carefully in a lab. My gosh, it could be only a matter of 5 years, 6 years, whatever, until we get these things in the lab and potentially could find life. That's just really exciting. Of course, you want to land Perseverance in a place where there was a lot of water once upon a time. We think those are the best places to look for life. And that spot is called Gizero Crater. It's about 30 miles across, and it has a river running through it here. You can see it, and a delta where water just spread out and deposited sediments. So it's going to be gathering samples in this region and bringing them back to the planet, Earth. A couple of other things that it's going to take along with it. I love this part of the mission. I think you will too. It's going to bring along 2 microphones. For the first time, we're actually going to be able, assuming they work, first time we're actually going to be able to listen to the planet. We're going to be able to hear the winds blowing on Mars and anything else that might pass by the microphone. Won't that be wonderful? What an extra great dimension to add. Besides seeing photographs, can listen to what it might be like to stand on the red planet. And this is just amazing to me. They're sending a helicopter along as well. It is the age of drones, isn't it? And this drone-like helicopter was built so it was able to spin fast enough with a powerful enough motor to make it through the thin air on Mars. And it'll be commanded by the rover itself, because these two have to communicate in real time the way you would if you had a controller and a drone here on the Earth. And you can't do that from the Earth. You can't control anything in real time on Mars because it takes the signal coming from whatever you want to control 16 minutes traveling at the speed of light to get to Mars, to get to the helicopter. So you can't do it in real time. So instead, the rover will do the commanding. It's got it all set up and ready to go. So we'll get some wonderful aerial views of the Martian landscape as if you were in a helicopter. One of the coolest things that I think we've brought back from Mars, or transmitted back, are photographs of the sky. Pictures showing the sunset and clouds like you saw earlier. But also, here's a picture where you get to see Earth and Venus in the Martian sky, the very same way that you and I get to go out at night and say, there's Jupiter, there's Saturn, hey, look, there's Mars. We are planets. Our planet is a bright spot, a little star in someone else's sky. And to see it like that just kind of brings it all to home that, wow, we really are a member of the solar system. We're just like the other planets too. So I love this photograph. I'm going to come back to you here for just a moment and check our time. And I hope you will spend 3 more minutes with me because I want to show you a wonderful video, a simulation of how Perseverance will land on Mars come next February. It's going to land the same way as the Curiosity rover did in 2012. That thing went off without a hitch. It was amazing. It's going to be using a special way of landing called a sky crane. And the video starts where you see the spacecraft after it leaves the Earth, moving through space, and then it arrives at Mars, and the bolts shoot off, the little rover is exposed, and then it begins to land. So I'll just show you the video. I think it speaks for itself. The volume here is a little funny. I'll try to turn it up as loud as I can so that you can hear it. So I'm going to go back and we'll give this a shot. And just stay with me a moment, and hopefully we can view this. Wow. I hope you got to see that. I hope you heard the sound too. That was harrowing. I can't believe it. Every time I see that, that inspires me. The work that the engineers that the space agency did to come up with that scheme. And they had to come up with that particular scheme because the thing is so heavy. It's about the size of a small car, but it has to be let down gently that way through what they call a sky crane. And then after it's set down on the surface, uh, the container, the rocket container that holds it, shoots off and gets out of the way so that the rover is safe. Then they don't crash together. Anyway, I hope you enjoyed that. The same thing is going to happen in February when Perseverance lands. And at that, I will leave it open for questions if you have anything you'd like to ask about Mars or any other astronomical topic.
Well, we give people a chance to answer questions. Would you like to tell us about our next Night Sky Explorer session?
Yes, next time we're going to talk about the farthest thing that you can see in the nighttime sky that will become visible after a couple of weeks, called the Andromeda Galaxy. So we'll start at our own Milky Way, which is absolutely spectacular these nights because the moon is not yet up in the sky, not bright enough yet. And then we'll leap from the Milky Way. We'll head all the way out to Andromeda. I'll show you exactly how to find it with your eyes and binoculars. And then we'll learn that the two galaxies will meet sometime in the future.
All right, I don't see any questions here. So we'll go ahead and wrap up our session today. And I'm just going to put up here where to find more information, that we have voyagers.org/dark skies to watch this. If you missed part of this, you can watch it at our website. You can also go to Astro Bob's website, areavoices.com, or find out more about Voyagers National Park Association at voyagers.org. So thank you, Astro Bob, for joining us and entertaining and educating us again today.
Thank you. It was a lot of fun. Thanks for having me. And keep looking up, everyone.